All right, guys, we're starting a new unit. It's called curve sketching. We're still going to work with the idea of the derivative and how it relates to graphs. And we start to look more of an abstract view using derivatives. But today we're just going to talk about things that you do know and link the first derivative algebraically to what it looks geometrically. So here, the first thing you have is this curve. I didn't even give you an equation to represent this curve because I wanted to just talk to you about the idea. If I'm looking for an x-intercept, you know the x-intercept is happening where the function crosses the x-axis. So in this case, I have 1, 2, 3 values where I have an x-intercept. What do we know about those points? The only thing I know is that the y value at all these points is equal to 0. So algebraically, if you're ever looking for an x-intercept, you set the function we should just say, you set y, let's cross that out, set y equal to 0. In your function, whatever the function's given, to find the x-intercept, you set y equal to 0. And then algebraically, you can solve it. Or geometrically, here's the y-axis. When y is 0, I'm looking where those curves cross. And so in this case, there's 3 points. So vice versa, if I'm looking for the y-intercept, you got it. You set x equal to 0. So here, when I'm looking, I have one x-intercept that's happening right there, and the value of x will always be 0 for the y-intercept. So that's something that I honestly don't think any of you will struggle with. And the way that I remember it is whatever intercept I'm looking for, you're going to set the other variable equal to 0. On my graph, I just put a and b here. So you could go ahead and draw that on your piece of paper. Why do you think I put a and b? What's happening when x is equal to a? I look here, I have a point. This point is considered a maximum. And here, this point is considered a minimum. So why do I find that important? Whenever you're curve sketching, we're looking for critical values. And one, besides your x and your y intercepts, which is part of creating the curve, we would also want to identify our maximum and mins. So that comes to where our first derivative comes into play. So if you look at this curve, and just remember, the first derivative, you know how to take the first derivative. You have 4 different ways of doing that: the power rule, the product rule, the quotient rule, the chain rule. That's all mechanics. But what did I say the first derivative is algebraically? Algebraically, it's the slope of the tangent line along that curve. So if you look here, if I'm drawing little tangent lines along this curve, you're going to see that that tangent line is leaning to the right. So it's a positive tangent line, correct? And then here at that a value that I just created, the tangent line happens to look like this. And then here, as I continue going along that curve, drawing little tangent lines, that slope value has to be negative because from left to right it's going down. So that is going to be the slope of the tangent line. The first derivative happens to be negative. Here at this turning point, again, the slope of the tangent line is horizontal. And when you continue, the slope of the tangent line is positive. So these little visuals are considered the derivative. And what is so important at what's happening at a max or a min? Your first derivative, the value, what's the value of a tangent line that's horizontal, the slope of the tangent, what's the value of the slope for any horizontal line? That value is always 0. So maximum minimums, which are also known as relative extrema. So that's just saying that there's some sort of extreme point, okay, a max or a min. When does that happen? You're going to look for what I call critical values. Critical values occur when the first derivative of a function is equal to 0, just like here. That first derivative is equal to 0. That first derivative is equal to 0. Or, which you don't have present here, but I'll show you in a minute, when your first derivative is undefined. That's when I just am able to identify if I have a possible max or min. Because here, the first derivative is equal to 0 and it happens to be a max. Here, the first derivative is equal to 0, but it's a min. So how do I go about saying, oh no, this one's a max and this is a min, without looking at the graph? What you're going to do is, after you identify those critical values, and in this case, my critical values would be A and B, you place the critical values that are identified, and in this case I identified them as A and B, on what I call a first derivative number line. So you're literally going to draw a number line, and you're going to label it the first derivative. And what you're going to say is, okay, where were those critical values? Where was the first derivative equal to 0? At A and at B. And you place them on the number line. Now, to identify if you have a max or a min, you're going to perform what we call a sign test. So perform the sign test on the first derivative. Now this is really important. People start getting confused. Do I perform the sign test on the original function or on the first derivative? It's always you perform that test on the first derivative. So here we have nothing algebraic to show you right now, because right now conceptually I want you to understand what we're doing. So if I have my number line here, and you know what, I'll just draw that number line over here again just so we can just follow with the graph. First derivative, my two critical values are A and B. Now I want to say, well, the sign test is telling me, is the first derivative positive or negative in this section? You don't test the value A, because A's always, those critical values will always be 0. But to the left of A, what was the value of that slope? Was it positive or negative? And in this case, to the left of A, it was positive. I had positive tangent slopes. To the left of A, to the right of A, those tangent lines have a negative value slope. And to the right of B, it's back to positive. So now let's look at what this means. If I have a positive, it means it's going up, the first derivative, and then going down. What does that look like it created? It looks like it created a peak. And there it is. That is a maximum. A max occurred when I had a sign change from plus to minus. What occurred at B when I went down to up? Doesn't that look like it's going down to a low point? Well, that's a minimum. So these two critical values happen to both represent a max/min, and then to be specific, the sign change is the order of the sign change is going to tell you specifically which one you have. So in your notes where it says a maximum occurs when, a maximum occurs when you have your first derivative equal to 0, or first derivative undefined, which it was the first part, and I do this means and, okay, and I have a sign change, but not just any sign change, it has to be from plus to then minus, okay, it can't be reverse. We call that increase to decrease. Your minimum occurs when you have your first derivative equal to 0, or your first derivative undefined, and I'm sure you can fill in the rest, and you have a sign change from minus to plus. So that is when max and mins occur. Interval of increase, well, the interval of increase of the original function can be told by the value of your first derivative. Look at my original function. If I'm tracing this, my pen is going up. Well, that's interesting. So from from the interval of negative infinity to a, my pen is going up. So look at my first derivative. From the interval from negative infinity to a, it's marked as plus. When is this function increasing again? Well, not from a to b. A to b, my pen's going down. From b to infinity, my pen is going back up. So therefore, it's increasing again from b to positive infinity, which the sign is positive. So intervals of increase occur when you know your first derivative is greater than 0, or also just if you just know the first derivative is positive. All right, so we get a lot of information from the first derivative test. Your interval of decrease occurs when, well, you know it, I'm sure. It's happening between a and b. This is going down. And what's the first derivative in that value? The slope is negative. So your first derivative is less than 0. That's negative. That's when your original function is decreasing. Okay, now this seems probably a little bit overwhelming, but don't worry, we're going to do plenty of examples, and definitely this video is going to be split into 2. So here we go with the next piece. You saw that the first derivative being set equal to 0 is a critical value. But then I just added this piece where the first derivative could be undefined, or the first derivative undefined. And you might be saying, well, how is that possible? Well, let's look, okay? If you're given this function, you guys know this is y equals the absolute value of x. Now, in order to be able to take the derivative, the function has to be continuous. So that should make sense. If I don't have a continuous function, well, then I can't draw a tangent line along it, so therefore I can't get a value for a derivative. However, here I have a continuous function, and I'm going to tell you right now that the first derivative at 0 in this problem is undefined. Now, why is it undefined? If I look at this and I draw a tangent line along this curve, you know that that tangent line is facing downwards. That's going to be a negative tangent. So I know that from negative infinity to 0, my first derivative here is negative. Okay. And then I know tangent line going up here, well, that's positive. But why I cannot say that the derivative here is 0. And the reason why is if I go to 0 from the left of this point and I create a tangent line right there, it's negative. But if I go to the right at 0, it's positive. I get 2 different values for the same x value. That is what we say when the first derivative is undefined. Okay, so that's a scenario where I'll say, well, this is a critical value, and I test and I'm going down to up. Well, there's a minimum here. There's a minimum, okay? And here, this is another scenario, okay, where I have, just because I have a critical value, it does not mean I necessarily have a min or a max. I could have neither. So if you look at 0 here, I do have a horizontal line. So I know that 0 is a critical value for this function. To the right of 0, the slope is positive. To the left of 0, the slope is positive. To the right of 0, the slope along that curve continues to be positive. So I do have a critical value, but I had no sign change. So this is what we call a shelf. We do not have a max. We do not have a min. We have a shelf. We have a critical value. Yes, my first derivative happens to be equal to 0, but I do not have a sign change. Okay, now we're going to practice algebraically, but I'm going to end that video right there and start a new one.